Hey, what's going on, guys? My name is Zero Davila. Welcome back to Save Our System IT. Today we'll continue with part number 13 of our Busybox series. Microcom is a minicom-like serial terminal emulator with scripting support. The requirement for this program was to be small enough to fit on a floppy-based Linux distribution, such as the one from Linux Router project. They managed to bring the executable size down under 70 kilobytes. Minicom is a communication program which somewhat resembles the shareware program Telix, but is free with source code and runs under most Unisys. Features include dialing directory with auto-redial, support for WCP-style log files on serial devices, a separate script language interpreter, multiple users with individual configurations, and more. Short for make directory, mkdir is used to create directories on a file system. If the specified directory does not already exist, mkdir creates it, and more than one directory may be specified when calling mkdir. The mkfifo command makes a FIFO special file with a name. FIFO stands for first in, first out, and it describes the way it works. Mode specifies the FIFO's permissions. It's modified by the process's umask in the usual way, meaning that the permissions of the created file are mode in umask. A FIFO special file is similar to a pipe, except that it's created in a different way. Instead of being an anonymous communication channel, a FIFO special file is entered into the file system by calling mkfifo. Once you have created a FIFO special file in this way, any process can open it for reading or writing, in the same way as an ordinary file. However, it has to be open at both ends simultaneously before you can proceed to do any input or output operations on it. Opening a FIFO for reading normally blocks it until some other process opens the same FIFO for writing, and vice versa. On success, mkfifo returns 0. In case of an error, mkfifo returns -1. mknod was originally used to create the character and block devices that populate /dev. Nowadays, software like udev automatically creates and removes device nodes on the virtual file system when the corresponding hardware is detected by the kernel. But originally, dev was just a directory in the root directory that was populated during install. So, in case of a near-complete disaster causing the /dev virtual file system not to load, and or udev failing spectacularly, using mknod to painstakingly repopulate at least a rudimentary device tree to get something back up can be done. Personally, I recommend a rescue USB stick or compact disc. The mkswap command sets up a Linux swap area on a device or in a file. The device argument will usually be a disk partition, something like /dev/sdb7, but it can also be a file. The Linux kernel does not look at partition IDs, but many installation scripts will assume that partitions of hex type 82 are meant to be swap partitions. Solaris uses this type. Be careful not to accidentally kill your Solaris partitions if you have any by mixing them up. The size parameter is superfluous but included for backwards compatibility. It specifies the desired size of the swap area in 1024-byte blocks. mkswap will use the entire partition or file if it is omitted. Specifying it is very dangerous. A typo can destroy your data, so I repeat, be very careful when specifying partition sizes manually. A typo can destroy the data on your disk. After creating the swap area, you need the swap on command to start using it. Usually swap areas are listed in a /etc/f tab, so that they can be taken into use at boot time by a swap on command in some boot script. The swap header does not touch the first block. A bootloader or disk label can be there, but it's not a recommended setup. The recommended setup is to use a separate partition for a Linux swap area. mkswap, like many other mkfs-like utilities, erase the first partition block to make any previous file system invisible. However, mkswap refuses to erase the first block on a device with a disk label, like a SAN, BSD and so on, and on a whole disk like /dev/sda. mktemp makes temporary files with unique file names. The mktemp utility takes the given file name template and overwrites a portion of it to create a unique file name. The template may be any file name with some number of x's appended to it, for example /tmp/tfile.xxx and so on. If no file name is specified, the default of tmp.xxx and so on is used and the -t flag is implied. The trailing x's are replaced with a combination of the current process numbers and random letters. The name chosen depends both on the number of x's in the template and the number of collisions with pre-existing files. The number of unique file names mktemp can return depends on the number of x's provided. 10 x's will result in mktemp testing roughly 26 to the power of 10 combinations. If mktemp can successfully generate a unique file name, the file or directory is created with file permissions such that it is only readable and writable by its owner, unless the -u flag is given, and the file name is printed to standard output. mktemp is provided to allow shell scripts to safely use temporary files. Traditionally, many shell scripts take the name of the temporary program with the PID as a suffix and use that as a temporary file name. This kind of naming scheme is predictable, and the risk conditions it creates is very easy for an attacker to win. A safer, though still inferior approach is to make a temporary directory using the same naming scheme. While this does allow one to guarantee that a temporary file will not be subverted, it still allows a simple denial of service attack. For these reasons, it is suggested that mktemp be used instead. Modinfo shows information about a Linux kernel module. Modinfo extracts information from the Linux kernel module given on the command line. If a module name is not a file name, then the /lib/modules/kernel version directory is searched. The same directory is searched by modprobe when loading kernel modules. By default, Modinfo lists each attribute of the module in the form field name : value. The module file name is listed the same way. Modinfo can understand modules of any Linux kernel architecture. Modprobe is for high-level handling of loadable modules. Module names must not contain paths, so no slashes, nor may they contain the trailing extension, like .something. This applies to the command line and to entries in the config. The modprobe and depmod utilities are intended to make a Linux modular kernel more manageable for all users, administrators and distribution maintainers. Modprobe uses a makefile-like dependency file created by depmod to automatically load the relevant modules from the set of modules available in a predefined directory trees. Modprobe is used to load a singular module, a stack of dependent modules, or all modules that are marked with a specified tag. Modprobe will automatically load all the base modules needed in the module stack, as described by the dependency file modules.dep. If the loading of one of these modules fails, the whole current stack of modules loaded in the current session will be unloaded automatically. Modprobe has two ways of loading modules. One way, the probe mode, will try to load the module out of a list defined by a pattern. Modprobe stops loading as soon as one module loads successfully. This could be used to autoload one Ethernet driver out of a list. The other way modprobe can be used is to load all modules from a list. With the option -r, modprobe will automatically unload a stack of modules, similar to the way rmmod -r does. Note that using just modprobe -r will clean up unused autoload modules and also perform pre and post remove commands in the configuration file /etc/modules.conf. Combining the options -l and -t lists all available modules of a certain type. Option -c will print the currently used configuration, so the default plus the configuration file, and the behavior of modprobe and depmod can be modified by the optional configuration file /etc/modules.conf. Note that the pre and post remove commands will not be executed if a module is auto-cleaned by the kernel daemon. Look for the upcoming support for persisting module storage instead. If you want to use the pre and post install features, you'll have to turn off auto-clean for the kernel daemon and instead put something like a line in your cron tab. This is used for kmod systems as well, to do auto-clean every 2 minutes. The idea is that modprobe will look first in the directory containing modules compiled for the current release of the kernel. If the module is not found there, modprobe will look in the directory common to the kernel version, like the version 2.0 and 2.2. If the module is still found, modprobe will look in the directory containing modules for a default release and so on. When you install a new Linux, the module should be moved to a directory related to the release and version of the kernel you're installing. Then you should do a symlink from this directory to the default directory. Each time you compile a new kernel, the command make modules install will create a new directory, but won't change the default link. When you get a module unrelated to the kernel distribution, you should place it in one of the version's independent directories under /lib/modules. This is the default strategy, which can be overwritten in the /etc/modules.conf file. And that's about it for today. Don't forget to like, share and subscribe. Any questions you might have are to be left down in the comment section or on our website www.sosit.co. Again, that's www.sosit.co. Thanks for watching and have a nice day.